All right. Hello, hello, hello. Welcome, ladies and gentlemen, to the Intrepid Sea, Air, and Space Museum's live virtual programming. We have new live virtual programming, so we'd like to thank you all for joining us. We look forward to hearing your questions throughout the programs, and we'll look to address as many questions as we can. Now, these museum live streams are free. And if you would like to support us in delivering these new exciting programs, please click on the link in the description below. Now, my name is Franz. I am a museum educator at the Intrepid Sea, Air, and Space Museum. And today we are celebrating something special. Today we are celebrating Lunar New Year. So we wanted to do something special for you all. So we have this program that we like to call Lunar Landers, okay? So today we're not only going to be talking about landing on the moon, which is pretty special in and of itself. We're also going to be talking about landing in other places, like back on Earth, landing on the moon, landing also on other planets, right? And we're going to talk about what it takes to land in different places, okay? Now, why are we talking about this? Well, in order to begin all of this, we need to talk about the ship, right? So this is the ship that I'm on, right? Or that we virtually are on, right? This is the Intrepid, right? And the Intrepid is an aircraft carrier. And today it's a museum. It's in the Hudson River on 46 and 12, right off the West Side Highway. You can go visit once we're open. But it is a museum, right? But the Intrepid once was an active aircraft carrier. And the Intrepid served back in 1943. It was made back in 1943, served in World War II, Vietnam, and the Cold War. In 1974, it was retired, no longer used for military service. And in 1982, it became the Intrepid Sea, Air, and Space Museum. Now, that name is pretty interesting, right? The name Sea, Air, and Space, right? Now, the Intrepid is a sea museum, obviously, because it was a seafaring vessel. It would have been in the Atlantic and Pacific Oceans during these particular wars, right? This is something that proves that it belonged in the water. This is a large propeller, right? Propeller that pushed the ship through the water. And as you can see here, the Intrepid did actually sail the seas, right? So this makes us a sea museum. Now, why are we an air museum? Well, we're an air museum because the Intrepid has airplanes, right? The Intrepid was an aircraft carrier. An aircraft carrier carries aircraft, but it also had the capability to have these planes launch and land like an airport that's in the water, right? So here is my favorite plane at the museum. This is the Avenger Airplane, right? And you can see this picture here showing jet planes taking off of an aircraft carrier. We still use this technology today. Planes take off from these ships if they're in the middle of the water, just so that way they don't have to do a long flight from one place to another, right? So that's why the Intrepid is an air museum, right? And we also still have aircraft on display, like our Fury here, which is a jet-powered plane, and our Retriever here, which is a helicopter, right? So that's the sea part, that's the air part, but the space part is the part that usually confuses people when they come, right? Because the Intrepid is a ship that was in the water, right? But the Intrepid has a special connection to outer space and has all to do with this, right? Now, ladies and gentlemen, this is a space capsule, right? And space capsules are things that astronauts would use to go up into outer space. Now, the one that we're looking at here is a replica, but it is a full-scale replica, meaning it's the same size as the actual one, right? You guys can write in the comments how many people you think could fit inside of this, right? Now, this is known as the Mercury Aurora 7 capsule, right? Now, during the space race, the United States was going against the Soviet Union, right? And they had a race to see which country could get all the way up to the moon the fastest. So they did it in steps. And this was one of the first steps that they did it in, right? And this program was called the Mercury program, right? And let's see what folks are saying. Maybe anyone can take a guess. And the answer is, ladies and gentlemen, one person. And this man's name was Scott Carpenter. There he is there getting inside of his spacesuit. Mr. Carpenter's mission was to ride inside of that capsule on the top of a rocket and then come back down to Earth. And this image here shows you how most capsules came back down to Earth. Now, As the capsule is in outer space, it's going to be going around the planet. It's going to be in orbit. And then what it's going to do is slow itself down and then come back down using gravity. Gravity is going to take it through Earth's atmosphere. And then we're going to need to slow ourselves down because now the capsule is moving way too fast. So then we're going to deploy parachutes. And these parachutes are going to come out and they're going to slow us down. Slow us down enough that we can splash down in the ocean. Now, these capsules splash down in the ocean for one reason, or two main reasons, actually. The Earth is mostly water. About 70% of it is water. So it's a pretty good target to aim for, right? And also, water is softer than the Earth, right? So you land in water, you have a better chance of having a safer landing, right? So that's why we're going to land in the water. And that's what Scott Carpenter did during this mission. Now, Mr. Carpenter had a little bit of issues when he landed. He fired his thrusters a couple of seconds too late and ended up landing over 200 miles away from where he was supposed to land. Then he got out of his capsule and didn't take his radio with him. So when NASA was trying to get in contact with him, they got no response. Eventually, though, a helicopter that says Navy on the tail there went out to pick up Mr. Carpenter because they eventually saw him floating in his raft. There his capsule is there with the raft next to it. And there Mr. Carpenter is there with a spacesuit. And where is this helicopter going to land when it's all said and done? Well, it's going to land right on Intrepid's flight deck, right? You can see Mr. Carpenter there in the spacesuit next to an Intrepid official on Intrepid's flight deck on the top of the ship, right? You can even kind of see the tail of the helicopter right behind him, right? And so that's Intrepid's connection to outer space. The Intrepid picked up capsules after they returned from outer space, right? After they did that splashdown in the ocean. Now, next, we have these two brave gentlemen, right? The gentleman on the far left here is Mr. John Young, and the gentleman here is Mr. Gus Grissom. These two astronauts also went into outer space inside of a capsule. They did 3 orbits around the Earth, and then they splashed down in the Atlantic Ocean. Now, this particular mission shares its name with a constellation, right? And is the constellation of the twins. I wanted to see if you guys can let me know if you know what the name of the constellation of the twins is. All right, so let me know, guys. But there the capsule is there floating in the water right next to the Intrepid. You can actually see sailors looking out in amazement as these capsules are floating in the water, right? Now, as we said before, these capsules are going to land in the water because the water, there's a lot of it, and it's softer, right? Capsules are built to a certain shape so that way they can actually float in the water. But then you're going to add these yellow flotation collars around it just so that way it can float while it's waiting to be picked up, right? And I see there's an answer in the chat for my question, my previous asked question about the name of this capsule. The name of this capsule is the Gemini 3 capsule. It's named Gemini because Gemini is the constellation of the twins, and there will be 2 astronauts inside of these particular capsules, right? Now, before we move on, I just want to take a second to see if there are any questions. Do you guys have any questions about any of the things that we've been talking about so far with capsules landing in the water coming from outer space? How burnt up is that capsule? So the capsule gets pretty burnt up. You see, when capsules come back down to Earth, because Earth has a lot of air, right? Our atmosphere has a lot of just gases are all around us, right? It's all pushing down on us, right? Because we're going through, you guys can try this at home. You can put your hands together like this, put your palms facing each other like this, and rub your hands together really, really, really quickly, right? And when you do that, you start noticing that you start generating heat, right? This is friction. And that's because all this energy is releasing itself in the form of heat. As you're coming through Earth's atmosphere, you're generating a lot of friction, meaning you're generating a lot of heat. Now, because of this, NASA had to put special coatings over all of the capsules and also put a heat shield on the bottom of the capsule that takes most of the heat, so that way it can move the heat away from the capsule to keep the astronauts safe. So it does get pretty burnt up, but the astronauts stay safe. Actually, later we'll see a capsule as it's kind of charred from when it came back from outer space. Any other questions? Okay. Why did they only send up 2 astronauts during the Gemini missions? Well, the reason why they only sent up 2 astronauts was because when you send up stuff, you have to send up fuel, right, for that stuff to go up into the sky. But then when you add fuel, you add in weight. So then you have to add more fuel. So you can see how this can become a problem. They got the right balance for the weight of the capsule and everything like that. And so they only used 2 astronauts. Also, they were building up. So as you can see, the first set of capsules, the Mercury capsules, only had 1 astronaut in it. The Gemini capsules had 2 astronauts in it. And so we're building ourselves up for our ultimate goal, which is to go to the moon. And that ultimately would have 3 astronauts. Was the Mercury the first thing to space? That's a very good question. So no, Mercury was not the first thing to go into outer space. We were sending up different satellites and things to go into outer space before we sent up Mercury. Sputnik is one of the most famous satellites that were sent up by the Soviet Union during the space race up into outer space. So we were sending up things like mechanical receivers and transponders in outer space before we were sending up capsules and humans and things like that. And maybe one more question. Let's see if we have one more question in the chat. Oh, that's a great question. Did all capsules land in the Atlantic Ocean? No, all the capsules did not land in the Atlantic Ocean. All the capsules that the Intrepid picked up did land in the Atlantic Ocean, but some of the capsules landed in the Pacific Ocean, like the Apollo capsule. So let's continue. Now, before we talk about the Apollo missions, because they obviously came after the Gemini missions, before we talk about that, we're actually going to skip a little bit in the historical timeline and talk a little bit about this. Now, if we look out, you can see the beautiful haze of the sky, right? The blue sky of the Earth, right? Kind of the reddish of the sun, right? Kind of coming into our atmosphere. But right here in the foreground, you see something very, very interesting, something that kind of resembles a plane. And ladies and gentlemen, that's no plane. That is a space orbiter, or for the sake of this conversation, a space shuttle, right? Now, this here is the Enterprise, right? And the Enterprise was the very first space orbiter ever built. And the space orbiter here is on top of a modified 747 passenger plane. You guys are looking at the craziest form of a piggyback ride you'll ever see in your life. Now, normally, when we send these rockets up into outer space, or these space shuttles up into outer space, they have those 2 solid rocket boosters on the side, that orange liquid fuel tank in the middle. You see lots of fire. You see it going up into the skies. But that's not what we're looking at here. And the reason why is because, well, when we built this, the technology wasn't completed. We had to test it to see if this bird had wings, if something so massive could glide through Earth's atmosphere and land on a runway, just like an airplane. You see, with those other capsules that we saw before, once they landed in the ocean, that was it. They weren't reused. NASA wanted something that could be reused over and over and over again. And they wanted something large enough that can go up into outer space and do things and bring things like satellites and telescopes and pieces of the International Space Station up into outer space. So they built the Enterprise to do this test, right? And so what we see here is this 747 passenger plane bringing it up to the sky to about 26,000 feet, going up to about 470 miles per hour. And then it just dropped it. And then the Enterprise did its magic. Those wings took over, right? You see, when these space shuttles go up into outer space, they use those rockets, they use that fuel, but when they come back home, they have no fuel. So how are they going to land? Well, they're going to use the same exact method as the capsules. They're going to rely on gravity. But unlike the capsules that use the parachutes, the Enterprise and the space shuttles, they're going to use those large wings to glide through the sky, manipulate the air around them, slow themselves down to come in for a landing, right? Now you can see here, this is actually Columbia. Excuse me. This is the Columbia spacecraft landing on a desert bed here, right? You can see it's landing just like an airplane lands, landing with these back wheels here, touching the ground first, and then those forward wheels touching the ground. So if you want to ensure that you can reuse your space orbiter, your space shuttle, then you need to make sure that it lands like an airplane on a runway. So that's how space shuttles were going to land when they came back, right? Now, what came after the space shuttles? Because the space shuttle program was retired in 2011. We no longer use space shuttles, right? So now we use something different. Now, before we talk about that, since we talked about the space shuttle program ending in 2011, we actually got the Space Shuttle Enterprise in 2012, right? And this is the Enterprise at the Intrepid. So once we reopen, you guys can come see the marvel that is the Enterprise. The Enterprise is on top of Intrepid's flight deck, and we have this structure built around it to protect it. But you can go inside the Enterprise, go nose to nose, get really close to it. You can even walk underneath the underside to see some of the tiles or some of the mock-up tiles that made the bottom of the Enterprise. So you can go and get really, really close to history. But another thing you can get really close to history with in the same exact space is what the technology that took place after the Enterprise in terms of American astronauts going up into space, right? And that's this, right? This is the Soyuz capsule, or the Soyuz spacecraft, right? And it's comprised of three main parts, right? Part number one here, this is your orbital module. This is actually what's going to connect you to the International Space Station. This is your re-entry module. This is what you're going to come back down to Earth with. And then this is your service module. This is where all your heating and cooling and electrical wirings and stuff are, all of your service stuff, right? Now, the Soyuz capsule was sent up into outer space by the Soviet Union back in the space race, right? The Soyuz capsule. But the technology has continued to go. So now the Russian Space Agency still uses this technology. And now, since we've retired the space shuttle program, only up until kind of recently, it was only these types of capsules that brought up American astronauts, right? And so these capsules were really important to not only bring up astronauts to the International Space Station, but also to bring up supplies to them if they needed them, right? And so what's really interesting about this, though, is the re-entry phase, right? The capsules that we saw before, they landed in the ocean. And one of the main reasons why they landed in the ocean is because of where they took off from, right? Mainly they took off from Florida, right? These rockets are taking off from Cape Canaveral, right? And Florida has a lot of water around it, right? And so that's a really good place for you to land. These capsules, though, are going to be taking off from a place that doesn't really have a lot of water, right? It has a lot of land. So these capsules are going to land a bit differently, right? This is the inside of the Soyuz capsule. You can see how tight it is, right? And it's tight for a specific reason. We'll talk why, right? Now, this is going to slow itself down just like the other capsules do. It's going to have a heat shield just like the other capsules do to protect it from getting hot. But this is where it's going to land. It's going to land on the ground, right? Smack dab, boom, on the ground, right? It's going to use a gigantic parachute to come out to slow itself down considerably, right? And then right before it hits the ground, if you can look at this picture here on the right before it hits the ground, you're going to see this large explosion, right? And that's because there are explosive bolts, or excuse me, explosives underneath the capsule that explode downward. And when they explode downward, the opposite thing happens to the capsule. It goes up. And this gives the capsule a little bit more time to catch a little bit more air in that parachute to slow it down just a little bit more before it comes landing down on the ground. Now, normally that would be very painful, but these astronauts are in specialized chairs. These chairs are form-fitted to their bodies, so that way when they land, they don't get jostled around. They pretty much just stay safe in their chairs, so that way they don't risk breaking anything. Now, a classic story is told about the capsules during the space race. versus the capsules that land in the deserts of Kazakhstan. The capsules during the space race era, you saw the astronauts afterwards kind of in sunglasses, chilling in the Caribbean sun, right? But these landings, you usually saw them in these stretchers because landing was still pretty shaky and bumpy. So there's a big contrast between the two, right? But landing in the same exact place, right? Landing on Earth has just showed us that we have to think about this in different ways. Landing 3 different ways: in the water, on land using things like the Enterprise or space shuttles, or landing right on land with capsules like the Soyuz, right? So I just want to take a little question break. I want to see if there's any questions that you guys are having about what we're talking about capsules landing, about capsules landing on Earth, about the space shuttles landing on Earth. How heavy was the Gemini capsule? I believe the Gemini capsule was about 2,000 pounds. It's pretty heavy. That's why they couldn't put too many things inside of it. When astronauts go up into outer space, they have a limited amount of supplies they can bring up. They even have to think about the water that they're bringing up in terms of their food. So their food has to be dehydrated because that puts up extra weight. So the capsule itself is pretty heavy, and then also everything that inside of it is adding to that weight as well. Okay. How was the Soyuz capsule used? Okay, so the Soyuz capsule was used by bringing astronauts and supplies up into outer space. It was a transport system almost. The capsules just pretty much brought things up into outer space. Unlike the capsules during the space race era, which were doing a little bit more exploration, right? The capsules that we send up, the Mercury capsule and the Gemini capsules, they were up in outer space, sometimes for a couple of hours, sometimes for a couple of days. And they were just kind of pushing the limits and seeing what we can do in outer space, right? So you can view the International Space Station, which is constantly orbiting around the Earth. You can kind of view that as those capsules, right? Just going up into outer space and just doing things in outer space, just to see how things kind of operate, see how your body kind of acclimates to space. But then the Soyuz capsule is more so for transportation, right? Even the space shuttle was used for transportation, but it was also used kind of to do work in outer space. That's to fix things and things like that. But the Soyuz capsule primarily is just for transportation, just to get someplace and then come home. What happens to the rest of the Soyuz parts 2 and 3? So whenever things separate, some of the things get kind of jettisoned out into space and just become space debris, but other things kind of fall back into Earth's atmosphere. Usually they fall down in large areas of water in the ocean, usually in the Indian Ocean. Like for instance, for the space shuttle, those rockets that fall off, they fall back into the ocean. They're retrieved and reused. But things like the Soyuz capsules, those parts that we talked about, some of it gets jettisoned and some of them actually fall back down to Earth. At that height, it's going to burn up into Earth's atmosphere and burn up like space debris. Any other questions? Is a really good one. So Aaron asked, where's the actual Gemini capsule, aka not a replica? I always forget what museum, and my colleague Alicia, she's in the chat. She can probably find out where exactly it is. So here we go. So I got kind of an answer. The Gemini capsules are now in DC, Texas, Oklahoma, Virginia, Ohio, Florida, Kansas, and I think, if I'm not mistaken, the Gemini 3 capsule is in Kansas. I think that one's in Kansas, the one that that we would have picked up. California and Illinois. Oh, so sorry. The Gemini 3 that we have is in Indiana, I think. I think that's what I'm being told. But they're also at lots of science centers, lots of different science centers around the country, just so that way people can see them. Gemini 3 is at the Gus Grissom Museum. Yeah. And maybe we can answer one more question. Maybe there's one more question. Or if not, we can move on. So let's move on. Oh, so there we go. How do capsules stop orbiting Earth? How do they get back home? Okay, so this is a really good question. Thank you so much, whoever asked this, because sometimes it's a little bit confusing. So when capsules go up into outer space, it's almost like they're being thrown into outer space, right? They don't go straight up. They kind of go up like this, and they go out of our atmosphere. And they're being thrown so that way they can go into orbit, right? And orbit is pretty much just going around something, because in space, there's no air pushing against you. You're going to keep going in that same exact speed for a very, very long time, right? And so that way you can orbit around something. The only way that you can come back home is if you slowed yourself down and then you let gravity take over. So these capsules get back home by strategically slowing themselves down by using retro rockets, and also just using a little bit of drag as they're starting to get lower into the Earth's atmosphere. And they use that so that way they can start to descend, right? So they can start to go down. And as they start going down, then they start doing maneuvers in order to slow themselves down by increasing drag, by putting out parachutes and things like that. So that's how capsules, pretty much in a nutshell, come back home. All right. So now let's talk about landing out of this world, right? We're going to talk about landing on the moon. By the way, this is the Soyuz capsule at the museum. You can see how beat up this one looks, but this actually did go into outer space. So unlike the other ones, this is not a replica. This truly was in space, right? Now it's time to talk about these brave gentlemen, right? Gentleman on the left, Mr. Neil Armstrong. The gentleman on the right, Mr. Buzz Aldrin. And the gentleman in the middle, Mr. Michael Collins, right? These three astronauts went to the moon, the two on the outside, right? Those two famously walked on the moon. Michael Collins stayed inside of the capsule and pretty much opened the door for the other two when it was time to go home, right? But their mission to the moon was very, very special, because it was the first time we ever landed anything with people on some other planet, right? Other place that wasn't our planet. And so landing there, though, was kind of a challenge. It's not like Earth, right? You guys can write in the comments, what are some differences between Earth and the moon? And some main differences that we have to think about when we land, right? So when these gentlemen took off, they took off in a Saturn V rocket and headed toward the moon, right? This trip takes about 3 days. 240,000 miles away, they headed toward the moon. But also, another Saturn V rocket took off, and it took off with something that they needed in order to land on the moon. You see, they couldn't just land their capsule like we land on the Earth, right? They couldn't land their capsule on the moon in water, right? Although the moon does have seas, right? These seas don't have water. They just look dark areas of land. So they called them seas. As a matter of fact, they landed in the Sea of Tranquility, right? They can't just land in water, though, right? They can't land on the ground, right? It's a lot different, right? Some people are saying weather is different on the moon. Some people are saying gravity, right? Gravity is different. Also, the moon lacks something very important for landing. An atmosphere, right? The moon has no atmosphere. It has no air to slow yourself down. So how are you going to land? Well, that thing that left out was called the Lunar Excursion Module, right? And it helped them land on surfaces that look like this, right? This is the moon's surface. The moon has lots of different craters, right? So that's another thing. Not only do we have to worry about landing without any air, right? Now we have to worry about landing on this bumpy surface, right? So I like to use this image because it kind of separates it pretty well. This is an image of the Lunar Excursion Module, right? Or sorry, the whole entire thing that went to the moon, right? And it's separated into 3 parts. Just like the Soyuz capsule that we saw before, this first part right here is going to be the service module, right? Where all the servicing stuff is, heating, cooling, all those fancy things, right? Then you have the main capsule, right? This is what's coming home, right? And then you have this weird looking thing on the end, number 3. This is the Lunar Excursion Module. This is actually connected to the rest of this while it was in outer space, right? And this is what the 2 astronauts that walked on the moon landed on, right? This is what it looked like landing. Kind of looks like something out of a sci-fi novel, right? With these weird looking legs, right? Very shiny because of that gold foil on the outside of it, shining off of the sunlight. And this is what it looked like when it landed, right? So we are going to have to use retro rockets in order to land, right? And actually, as they were landing, they started using a little bit too much of their fuel for their retro rockets. And this could have been a problem because they used up most of the fuel in that fuel cell. Luckily, they had some in the reserve, but they had to use that extra fuel because they had to overshoot where they were supposed to land because there were some rocks there that they didn't really anticipate being there, right? And so these legs are very, very important for this, right? Because as it lands, it's going to kind of land with these legs like a spider kind of stands on the ground, right? With these legs kind of anchoring it. And it has these joints here to take out some of that shock, right? And that's something that we really need to worry about on a place like the moon. If you ever think about the moon landing and astronauts jumping around on the moon, when they jump up, they do come down, but it takes them a little bit, right? It would be disastrous if this thing landed and bounced, because then the astronauts inside of it could be really, really hurt, right? So they had to take all of this into account when they were landing, or they're planning on landing on the moon. But not only that, you see, we also weren't going to leave Neil Armstrong and Buzz Aldrin on the moon, right? We had to get them off the moon. But there were no rockets to get them off the moon to reconvene with Mr. Michael Collins, who was in the getaway car, as we say, orbiting around the moon. So how did they get off the moon? Well, this thing also separates into two separate parts. So this top part is the ascent stage. That's the stage that goes up. And this bottom part here is the descent stage. That's the part that stays on the moon, right? So the ascent stage separates, and then those astronauts can go back up to the capsule, reconvene with Michael Collins, and then head back to Earth, where they're going to splash down just like the other capsules did. So landing on the moon was a whole ordeal that needed a whole nother spacecraft in order to make it happen, to allow it to happen, right? So that's not the only place we landed, right? It's not the only place by a long shot that we've landed, right? It's the only place we've landed humans in other places, right? But we've also landed rovers and different probes on different planets, right? And so what I want to do right now is talk to you guys. Oh, I forgot to show you this real quick. This is the ascent stage, by the way, going up. You can see the moon kind of doing a little moon sunrise, but moonrise over here, right? And you can see down here, the ascent stage coming up to meet Michael Collins, who actually is taking the photo in this picture, right? Now, let's talk about the Mars rovers, two of the very famous Mars rovers, all right? We have this one, Spirit and Opportunity. Now, you might think that I kind of doubled up on the pictures here, but believe it or not, they're twin rovers, so they looked almost the same, right? And so these two rovers went up to Mars, and they did some really, really important things. But I want to play a quick game with you guys, and I want to see if you take your best guess with this. I'm going to ask you guys some facts about the rovers, and I just want you guys to write 1 in the chat if you think the answer is Spirit, and then write 2 in the chat if you think the answer is Opportunity, all right? Just write 1 or 2. So the first one is, which one do you think went the farthest? Which one do you think went the farthest? Now, to give you guys a little bit of background, these both took off in the summer of 2003 and landed about a year later in 2004. All right. But which one traveled the farthest? So I see some 2s for Opportunity. I see some 1s for Spirit. Okay. 2s and 1s. Okay. And I'll give you guys the answer. The answer is Opportunity. All right. Spirit went 4.8 miles and Opportunity went 28 miles across the Martian terrain, right? So Opportunity went farther. We'll talk about why in a little bit. Which one of these got some help from a dust devil? Which one of these got some help from a dust devil? Was it 1, was it Spirit, or was it 2, Opportunity? We'll talk about what a dust devil is, right? Because I will say Mars is really, really dusty. Lots of things that look like sand, right? All that red stuff that coats the cover, the surface of Mars. And I see lots of ones, two. Oh, it's ones and twos. I see some ones and twos here. And the answer is, ladies and gentlemen, Spirit. Spirit got some help from a dust devil. So this is what happened. See, Mars has these storms and dirt and dust flies around and it covers things, and it covered Spirit's solar panels where it gets its energy from. And because of this, its batteries were dying and it needed some help. So luckily, the thing that kind of got it in trouble kind of got it out of trouble too. This is a dust devil right here, kind of like a tall dust column that came and brushed the dust off of the solar panels so Spirit can keep on with its mission. So the thing that kind of took its power away gave it its power back later, which is kind of cool. Now, which one of these had a broken wheel that made a great discovery? Was that Spirit or was that Opportunity? Right? Now, both of these were doing lots of different tests. They were scouring the Martian terrain, looking for different evidence of organic molecules. They were looking for evidence of life, right? They were looking for evidence of water. They were looking for lots of different things. But one of these things made a great discovery by accident. And I see some ones, a few twos, and let's see what it was. And the answer is, ladies and gentlemen, Spirit. And this is actually why Spirit's mission, this is the reason why it didn't travel that far. It's because it had this broken wheel, right? Now, as it was kind of going across the Martian surface, it was kind of dragging this wheel, and it noticed something. It noticed that it kicked up some weird stuff, right? And when we analyzed this stuff, we noticed that it had organic compounds in it. And this actually proves that Mars has some of the ingredients for life. Right? It has the water, it has some organic compounds. So it didn't prove that there was life on Mars, but it did get us a little bit closer to understanding a little bit more about Mars, right? And then the last question is, which one had the longer mission length? Which one had the longer mission length? Do you think it was Spirit, 1, or do you think it was Opportunity, 2? What do we think? Which one had the longer mission length? And I'm seeing lots of 1s and 2s. And this is the answer, ladies and gentlemen. Opportunity did, right? Whereas Spirit, because of that broken wheel, lasted about 6 years, which is very impressive. Opportunity lasted about 15 years. So we can see that these two rovers, although they had different time lengths, they still did a lot for us and helped us understand things. Let's talk a little bit about how they landed, because they landed kind of similarly to the way that certain things land back on Earth, but the parachute, it even has retro rockets, right? But if we look down here, we can see something interesting. We see these things that look like grapes. These are inflated and almost act like balloons. These protective balloons that are around these rovers. This is important because even though we have this parachute, Martian air is still a lot thinner than Earth air. So we need to slow ourselves down considerably, but we also have to worry about the shock, right? Because gravity works a little bit differently there. So we're going to use these bouncy balloons, and we're going to bounce up really, really high until we come to a stop. Right? And then these balloons are going to deflate. Kind of looks like a raisin. It's going to open up and reveal this, the rover, golf cart-sized rover, right? But there was another rover, really cool rover that I like a lot. His name was Curiosity. Curiosity landed a little bit differently. Because Curiosity, ladies and gentlemen, was about the size of an SUV. So it was really big. So it has to land a little bit differently. So this is a little bit of a video showing you it landing, right? So I'm just going to see if I can enlarge this here so that way we can see it. Here we go. So we can see this is the encasement for the rover, right? So the rover's inside there, but as we go a little bit farther down, we're going to see that we're going to enter the Martian atmosphere. And just like our Earth, we take our hands and rub our hands really fast together and we get that friction again. It's going to generate a lot of friction too. It's also going to generate plasma, really, really hot plasma in the front of the capsule as it's kind of coming into Earth's to the Martian atmosphere, excuse me. There it is there, coming into the atmosphere. You can see the air coming off of the sides there. Once it gets to a decent height, it's actually going to deploy that parachute again, right? Just the same as the other the rovers that we saw before. And the parachute's going to come out, and it's going to slow it down. But I want us to pay close attention to what happens at the bottom part here. Right now, there's a heat shield, right? And this heat shield is made out of pretty much a fine grade of glass that's protecting it from heat. And now we're going to get rid of it. And now we can see something on the underside. That's actually the rover being exposed. So now we have to deal with the shock of landing. So what are we going to do? We're going to use retro rockets as it comes out. But then we're going to separate from the actual rover and drop it off. So this way, the rover doesn't come crashing down to the ground, right? It can actually be gently let down. That thing that you saw letting it down and flying off to Mars, it goes and flies off pretty far away and crash lands into Mars. And I think, if I'm not mistaken, later in Curiosity's mission, I think it found that as it was kind of surveying Mars's landscape, which is pretty interesting, right? So landing on different places, right? Landing on the Earth, landing in the water, landing on the actual ground, right? Landing on the moon, and then landing on other planets. It all takes different things, right? It takes us thinking differently about that stuff. So I want to thank you guys so much for joining me for Lunar Landers, but I do want to open the floor for maybe about 2 or 3 questions that maybe I can answer really quickly. Oh, did all Apollos land on the moon? That's a great question. No, not all Apollos landed on the moon. Some of the Apollo missions just went and orbited the moon just to see, like I said, everything, we took steps, and it's almost like dipping your toe into the water and your whole foot and then, your whole body into the water, right? It's taking different steps to go onto the moon. So we went to the moon, orbited it. We actually went to the moon without any people on it. And then actually the Apollo missions that were supposed to go to the moon and have astronauts walk on it, Apollo 13 actually didn't because there was an issue. And actually the Lunar Excursion module acted as almost like a life raft. So that thing that landed the astronauts on the moon actually saved those astronauts and took them back home, gave them enough power to go back home. But that Apollo mission did not land on the moon. So that's a good question. Any others? Have the rovers come back from Mars? Unfortunately not. There's no propulsion to actually get them to go off of Mars. And actually, that's something that scientists are really thinking about when astronauts go and land on Mars. One of the things they're thinking about is how they can fashion a rocket pretty much to get off of Mars to come back home. So it's a one-way trip to Mars for these rovers, unfortunately. Maybe one day when we send humans there, maybe they can find them and bring them back, maybe. Who knows? And maybe we could do one more. Oh. Is someone controlling the probes like a remote control car? Yes, they are kind of controlling them like a remote control car. And there's also a little bit of latency. I believe it's a couple of minutes. I forget how many minutes it is. But so like when you do something here on Earth, it takes a couple of minutes for that to respond on Mars. So yeah, they are controlling it. Oh, and I see that maybe you can. Why did Spirit and Opportunity not have air compressors to clear the dust? That's a very great question. I'm not necessarily sure about that. Maybe my colleague can look into that. But I would imagine it'd probably have something to do with the weight and bringing extra things up into outer space, up into Mars, and the weight. I also think that maybe just adding that extra component, they didn't necessarily deem it necessary, but I'm not sure. Maybe we can look into that. And wait, I'll put up this question. How about this one? How does NASA select astronauts for the mission? That's a great question. So they have to go through rigorous training. They go through mental evaluation. They go through like school training, and then they also have to do physical training. And then pretty much they just keep putting them through tests, and the ones that perform the best, then they go up into space. So. And maybe one last question. I'll put this one up from Fatima. She asks, did they find any water on Mars? So they found like water ice, not really like flowing liquid water, but there's lots of evidence that there was water on Mars, like canals and old river channels. But no like lakes or rivers or anything like that have been found on Mars as of yet. But the evidence that Mars does have some type of water, like water ice, there's evidence that Mars has water ice, but no like flowing water or anything like that. All right. So, ladies and gentlemen, I want to thank you all so much for joining me for the special Lunar Landers program. We do these programs free. So if you guys feel inclined, you can click in the description to find out how you guys can join us for this. Also, I forgot to mention, we're talking about the rovers. Next week, the next rover, Perseverance, is actually going to be landing on Martian surface, and we are going to be showing that during our Kids Week celebration. So come for our Kids Week celebration. You guys can find more information about this at intrepidmuseum.org. It is a week-long celebration next week, virtual, where we're going to be doing lots of different fun activities and lots of different fun presentations. And one of those presentations is actually seeing Perseverance and witnessing the landing moment of Perseverance on Mars, which would be a tremendous moment. So thank you guys so much for joining me. And actually, I just want to also put up a little information card about the next program that we're going to be having in about 10 to 13 minutes. And I will share this with you all now here. Oh, sorry, guys. Having a bit of technical difficulties. There we go. So thank you all so much for joining me for the Lunar Lander program, and stay tuned for our next program in about 12 minutes. So All right, ladies and gentlemen, I'd like to welcome you guys back. Thank you so much for sticking around for our special programming today. As I mentioned before, today is Lunar New Year, so we thought to do some really cool programming around the moon today. So I'd like to introduce my great friend and partner that's coming on next. His name is Brian Day. He is the lead for lunar and planetary mapping and modeling at NASA's Solar System Exploration Research Virtual Institute. All right, so join me in welcoming my friend Brian Day to the stream. So Brian, you're all ready? Give me a thumbs up if you're all ready. All right, here we go. Hello, Brian. How are you? We just ask that you just unmute yourself there.
Great to see you, Franz. Happy New Year.
Happy Lunar New Year to you as well. Nice hat, by the way.
Oh, thank you so much. So I'm going to try and share my screen here, and let's see here. Share screen, and I'm trying to just share one. I guess I have to share. I have to share the whole screen. I can't just share a window. Is that correct? I'll do it this way. This should work. So, so with any luck, you are now seeing my slides. Are you seeing my slides? Hello? So I'm assuming you're hearing me. So
Brian, so you're just gonna go to we're just gonna have you go to share, and then you're going to let me stop that there. There you go. And then now if you go to making that your screen larger there.
So just go to full.
There you go.
Okay, very good. All right. So thank you very much. We are going to talk about lunar landing sites, past and future. We've been to some really fascinating places on the surface of the moon before, and we're looking to go to some more interesting places in the future. So looking back, between July of 1969 and December of 1972, there were 6 Apollo missions that took a total of 12 astronauts to the surface of the moon. They went to a variety of interesting places, but we can see that all of the places they went were on the near side of the moon, and all of them were pretty much at mid-latitudes. None of them went to the poles. The first of the missions was Apollo 11, in which Neil Armstrong and Buzz Aldrin landed on the surface of the moon, while we still had in orbit a Michael Collins waiting for them to return. Now, their landing site was on the southwest portion of the Sea of Tranquility. And this area was chosen not because it is necessarily particularly interesting from a science standpoint, but because as you look at it here, you'll see that the area around it is very rough and very rugged. But the Sea of Tranquility itself is very smooth. It is flat, ancient lava plains. And that flat, smooth area seemed like a good, safe place to land the first human mission to the moon. And so here you can see nice, smooth, flat areas. It seemed like a great plan. But the guidance computer of the Lunar Module had other ideas in mind and was actually taking the astronauts down toward this crater, which is covered with boulders about the size of automobiles. And Neil Armstrong looked out the window as they were coming down and realized, my gosh, we can't land there. So he took control of the spacecraft with only seconds of fuel remaining and manually flew it off further to the west. And if you look closely here, you can actually see the image of the descent stage of the Lunar Module where he safely landed. We'll zoom in here. The descent stage, this is what they rode down to the surface of the moon on, is still visible here today. If you look down below, you can see some reflections of some of the equipment that they set up on the surface, some of the scientific equipment, including a laser retroreflector and a seismometer. And if you look very carefully, you can see some dark squiggly lines. These are the actual footprints that Neil and Buzz left on the surface of the moon. Pretty amazing. Our next Apollo mission was Apollo 12. Pete Conrad and Alan Bean went down to the surface of the moon, while Dick Gordon remained in orbit in the command module. Here they went to an area called Oceanus Procellarum. Again, a very flat, smooth area. But you'll notice in the map up above, you can see a very prominent, this is Copernicus Crater. And Copernicus Crater is one of a set of landmarks we use on the moon to kind of help us gauge the relative ages of features on the moon, the lunar chronology or timeline. And so what we wanted to do is find out exactly how old Copernicus was to help nail down that timeline. Unfortunately, Copernicus itself is too rough and rugged to land in. But what people realized is, as you look down into the flat plains of Oceanus Procellarum, there's a spray of debris that was ejected from Copernicus Crater. And so if we landed on that spray of debris, we'd be able to collect some of that in a nice safe area and hopefully figure out how old Copernicus was. So here we are zooming down to the nice flat landing spot, but again, with sprays of material from Copernicus. And as we look at the landing site, again, you can just make out the lunar module there in the upper above center. And while Apollo 11 tried to avoid craters, in the case of Apollo 12, we tried to get near craters, because what happened here is we wanted to look at areas that had been excavated so we could see different layers of material. And so we allowed the craters to do the excavation for us. You may be able to just make out again some thin lines, dark lines that are the paths of the astronauts as they wandered around. In closer view here, you can see the lunar module. There's another object down here. This was an example of a pinpoint landing. They landed right next to where the robotic Surveyor 3 spacecraft had landed 2.5 years before. And here you can see they actually walked up and retrieved some of the equipment off of Surveyor 3. You can see how close the lunar module landed to Surveyor 3. This was indeed a pinpoint landing. Apollo 14 carried 3 astronauts to the moon. 2 of them actually landed on the surface. That was Alan Shepard and Edgar Mitchell, while Stuart Roosa remained in orbit. Alan Shepard was actually the United States' first astronaut. He flew first in the Mercury program. And this explored a region of the moon that was telling us a very interesting story. If we take a look at this overall view of the moon, and you remember Copernicus Crater, down here you can see the Fra Mauro Highlands where Apollo 14 landed. But up above Copernicus, you can make out something like a large oval area. And this is Mare Imbrium. Mare Imbrium is another one of these big impact structures. And it's one of the one of the features that helps us figure out the timeline of the moon. Now, with Apollo 12, we were able to figure out that Copernicus is about 800 million years old. It's old for something here on Earth, but for the moon, that's quite young. But now we wanted to figure out how old this Imbrium Basin was. And the Fra Mauro Highlands is, unlike the flat lava plains we had been to before, this is an area of rolling hummocky hills formed by material that had been blasted out of that Imbrium Basin when an asteroid crashed into the moon and formed that basin. And so we didn't actually go to the Imbrium Basin itself because sometime after it had formed, it got flooded with lava. And so landing in the Imbrium Basin would tell us how old that later lava was, but now how old the basin itself was. So we went to stuff that had been blasted out when the basin was formed. And here you can see, again, the lunar module. It's very small down here in the lower left. And the astronauts made their way to the edge of Cone Crater that, again, had done some nice excavating for us in that area. Now, of course, along the way, they were collecting rocks. And rocks are really important things to bring back from the moon. If you're a geologist, rocks end up telling you stories. They tell you stories of how they formed, when they formed, the conditions under which they formed. And here on Earth, we would love to find rocks that could tell us the stories of the earliest days of the Earth. But because of erosion and plate tectonics, we have no rocks remaining from those earliest days. But on the moon, there is no wind, there's no rain, and so we can find rocks that are far, far, far more ancient than we find here on Earth. And since the Earth and Moon formed together in a giant collision about 4.6 billion years ago, finding these rocks on the moon can perhaps give us insights into rocks here on, or into the history and the formation of Earth. Now, this is one of the rocks they found near the edge of Cone Crater. It's about the size and shape of a football, and it got the nickname of Big Bertha. But Big Bertha turned out to be a very special rock indeed. It is what we call a breccia. It's a bunch of different types of rocks that got fused together by the heat and energy of an asteroid impact. And one of the rocks within Big Bertha tells us a very interesting and amazing story indeed. It seems that when we listen to the story that this piece of rock has to tell us, it seems to be saying that it didn't actually form in the moon at all. It actually formed here on Earth between 4 and 4.1 billion years ago at a depth of about 12.4 miles. Now, back in the solar system was a very violent place, and asteroids were constantly pummeling the Earth. And so some of the material from the Earth got blasted into space by one of those impacts, including this rock. And this rock flew out into space, and then it apparently landed on the surface of the moon. But it didn't get to rest there in peace very long, because then 3.9 billion years ago, the impact that formed the Imbrium Basin happened. And from the standpoint of our little rock, it would have seen this giant tsunami of hot molten stuff come over the northern horizon and bury it and fuse it to the native moon rock around it. And there it should have remained for the rest of time, except for the fact that 26 million years ago, another smaller asteroid hit, formed Cone Crater, excavated our little rock, left it out on the surface, where then later on, Alan Shepard came along, saw it, liked it, picked it up, put it in his bag, and brought back home. So as a result, it appears that the oldest Earth rock we have ever seen was kept and preserved for us by the moon. Apollo 15 then followed with Commander Dave Scott and Lunar Module pilot James Irwin, with Command Module pilot Al Worden. And they went to the Imbrium Basin area, right to the edge of the Imbrium Basin. And on the edge of the Imbrium Basin, you have this mountain range, the Apennine Mountains, that are about the height of the Alps here on Earth. So they're significant mountains. But the reason that we were drawn to that is that they are composed of this ancient highland material, much older than the lava-flooded plains that we had been visiting before. And so landing in the nice flat lava plains, they're safe to land in, and then moving up to the edge of these mountains, we were hoping to be able to find some of this rock from the ancient highlands and learn about the even earlier history of the moon. And as we look at that edge between the lava plains and the mountain front, we see something very strange. We see something that almost looks like a dry riverbed. This is called Hadley Rill. No water actually ever flowed here, though. This was carved by flowing lava that erupted from vents here in the lower left and then streamed out for about 60 miles across the lunar plains. So a lot of interesting stuff is happening here. Now, this is the first Apollo mission where they actually took a car with them, a lunar rover. And so they were able to cover much more distance. And here you can see Hadley Rill, about, a mile across, about 1,300 feet deep and 60 miles long. And in the distance is Mount Hadley Delta in that mountain range. And they actually drove up to the lower slopes of Mount Hadley Delta and were able to collect some of that ancient lunar crust. On their way back, though, it turns out they had spent more time on the slopes of Hadley Delta than they were originally scheduled to. And so Mission Control got a little bit nervous and said, you know, you're running behind schedule. Forget all the rest of the stops on your schedule. Just head right back to the Lunar Module. Well, that was a little disappointing to the astronauts. They had looked forward to making the additional stops, but they understood they needed to get back with their consumables. But Dave Scott's a smart guy, and he realized they still had plenty of buffer. And as they're driving along, he looks off to ahead of him to the right and sees this amazing rock. And he immediately realized he wanted that rock. But he also knew that if he told Mission Control he wanted to stop and get that rock, they'd tell him no, just go back to the Lunar Module. So he came up with a plan, and he radioed Mission Control, and he said, hey, I'm having a problem with my seatbelt. And Mission Control radioed back, well, that's a safety issue. Stop right now and fix your seatbelt. So he stopped, unclipped, jumped out, ran, grabbed this rock, came back in, snapped back in. He said, seatbelt's fine, and drove back to the Lunar Module. And as a result, brought back this amazing, what we call vesiculated basalt rock that has popularly become known as seatbelt rock. So with Apollo 16, we were now ready to go and land in the rough, rugged, and incredibly ancient lunar highlands. We'd gotten pretty good at lunar landings at this point, and so people were willing to take on the challenge. Commander John Young and Lunar Module pilot Charlie Duke descended to the lunar surface while Tom Mattingly waited for them in orbit. And so again, this was going to the rugged lunar highlands, to the Descartes Highlands specifically. And as you look down, you see this looks dramatically different than the terrain we had been to before. Again, this is truly ancient crustal material from the early formation of the moon. And there was a crater nearby, North Ray Crater, that they drove right to the edge of and were able to sample, again, multiple layers of material that had been excavated by the formation of this crater. The final Apollo mission to actually go to the moon was Apollo 17. And this was commanded by Gene Cernan. And it also carried the first actual professional scientist, a geologist, Harrison Schmitt. So Cernan and Schmitt went down to the lunar surface while Ron Evans waited for them in lunar orbit. They went to a very spectacular area, the Taurus Littrow Valley, on the edge of the Sea of Serenity, or Mare Serenitatis. Here we see Mare Serenitatis, and in the lower right, we have the Taurus Littrow Valley. This is about as deep as the Grand Canyon. Actually, it's deeper than the Grand Canyon here on Earth. So we've gone from something very safe, like landing in the Sea of Tranquility, to really shooting into this really challenging target. And as we look at the floor of the Taurus Littrow Valley, we see coming off the mountains to the south a giant bright landslide deposit extending for miles across the valley floor. Here you can see the view as they would be coming down toward this valley. You can imagine this would have been a really exciting approach. Here you can see looking down at the actual descent stage of the lunar lander. And this is the view they had looking to the north, looking at the mountain North Massif. And if you look very carefully, you may see tracks coming down the face of the mountain and boulders at the end of the tracks. These are boulders that had rolled down the slope of the mountain. And because of the tracks, we could tell exactly where they originated from in these mountains. And as a matter of fact, this boulder here on the right is one that they actually drove up to and visited and were able to collect material from. They also ventured down to the mountains to the south, to South Massif Mountain, and that giant landslide that poured down off of it. A crater called Schrodinger Crater in that landslide area turned out to be really interesting. As they were walking around it, they noticed that the soil they were kicking up revealed beneath it orange soil. Very different than the typical flat grays that they had been seeing elsewhere. And it turns out this orange soil was composed of beads of volcanic glass that had been erupted in fire fountains, volcanic eruptions long ago on the moon. For these views here, I'm using software called NASA's Moon Trek portal. I'll tell you a lot more about that, but using the Moon Trek portal, we're able to have a view that our Apollo 17 astronauts never got to have. This is sitting on top of South Massif, looking at that incredible landslide deposit stretching out across the valley. And of course, there's great question as to what caused this landslide. And after analysis, we think we now know. Looking down at the Taurus Littrow Valley, you can again see the bright area of the landslide, but you can also see this dark line stretching across the valley and into the mountains to the north. This is called the Lincoln Scarp. This is a fault scarp. And it turns out this is an area where we have indication of the moon. As time goes on, it's cooling. And as the moon cools, it shrinks. As the moon shrinks, the rigid crust buckles and forms these fault scarps. Based on seismometers left by the Apollo astronauts on the moon, we can see that there's still active moonquakes today. And some of those quakes originated along the area of this fault scarp. So it is quite likely that moonquakes generated along earthquake faults like this generated the actual landslide. So with that, the Apollo missions to the moon were over. But that doesn't mean our exploration of the moon was over. Following the Apollo missions, we had a number of robotic probes, including Clementine and Lunar Prospector, which gave us clues that there might be deposits of water ice at the poles of the moon. Now, we weren't sure about that, but it seemed interesting because Apollo told us that the moon was a bone-dry, absolutely arid place. So how could there be water ice at the moon? Well, it turns out at the poles of the moon, the sunlight is coming in horizontally instead of shining straight down like it would on the equator. And because it's coming in horizontally, the rim of any crater will cast a shadow. Now, there are craters at the poles of the moon whose floors have been in shadow for over 1 billion years. Because they're so very, very dark, they're very, very cold. And so we think that ice might be able to accumulate in places such as that. So to test this out, we sent a pair of missions, the Lunar Reconnaissance Orbiter and LCROSS, the Lunar Crater Observation and Sensing Satellite. They launched together on an Atlas V rocket on June 18th, 2009. It was a very exciting day. It was a beautiful launch to watch. And I'll talk about, they launched together on the same rocket. I'll talk about LCROSS first. They included what we called the shepherding spacecraft with all the scientific instruments aboard. And it also included the upper stage of our moon rocket, the Centaur upper stage, something about the size of a school bus, weighing 2 metric tons. Again, about the size of a school bus, but moving considerably faster than your average school bus, about 5,600 miles an hour. As we approached the moon, we turned around and LCROSS released that upper stage and sent it flying down into one of those permanently shadowed craters. It slammed into the ground at 5,600 miles an hour, blasted a cloud of debris up out of the shadows, into the sunlight, high into the sky of the moon, and then our little robotic spacecraft dove down into that cloud of debris, sniffed it, and analyzed it, and that's how we discovered water ice on the moon. In the meantime, our sister spacecraft, LRO, the Lunar Reconnaissance Orbiter, is still in orbit around the moon today, and it is mapping in great detail the lunar surface. It's measuring With laser altimetry, it's measuring precisely all the ups and downs on the surface of the moon. It's measuring the temperature of the moon. It's peering into these dark, shadowed areas. And one of the things it discovered is that these permanently shadowed areas on the moon are actually the coldest places we have measured anywhere in the solar system, even colder than the surface of Pluto. And it is verified that, in fact, there are large deposits of water ice in those permanently shadowed areas, and even extending out underground as permafrost in areas around those permanent shadows. So then looking ahead, we had a conference to examine where we want to go with future missions. And you can actually download the results of that meeting. That meeting happened in 2018, but since then we've continued to study the moon and even add more sites. And so what I'd like to do is show you some of the places that we look to go in the future to the moon. One of these is Reiner Gamma, probably the best example of what we call a lunar swirl. If we look at the surface of the moon, look up at the full moon as you'd see in the sky, Reiner Gamma is at the extreme western edge there, a little bright spot. It's visible in small backyard telescopes. Looking at it, you may see it look best during full moon time of view with that flat lighting, and it almost looks like a tadpole in shape. As you zoom in, you see it's composed of these serpentine swirls of light and dark areas. See, it's actually completely flat, but you have these weird patterns of light and dark. Now, it turns out that the moon no longer has a global magnetic field the way the Earth does, but it does have remnant localized magnetic fields. And this area is where you have an example of a localized magnetic field. And so what it seems to be here is these light and dark areas are actually tracing out the field lines of that local magnetic field. Now, why would this area have its own magnetic field? We don't know. That's one of the reasons why we want to go there. Another area we want to go is very nearby, the Marius Hills. So just north and a little bit to the east of Reiner Gamma, you find the Marius Hills. In fact, there you can see Reiner Gamma in the lower left. The Marius Hills are pretty much in the center of this field of view, and they are the most spectacular collection of volcanoes on the moon. Now, I'm not seeing much that looks very spectacular here. That's because lunar volcanoes tend to be very flat, low-profile objects. But if we use that laser altimeter that we were talking about on LRO to precisely measure the ups and downs, they pop into view. You can see this cluster of volcanic cones and domes, many dozens of them. And this area formed over a long period of time, well over 1 billion years. And so exploring this area would allow us to examine the chemical and structural evolution of the interior of the moon over time. Really a fascinating area. And again, you can see channels that were carved by flowing lava. Another area that we want to explore is actually two areas right next to each other, the Aristarchus Plateau and the P60 basaltic unit. So here we have, again, from the Marius Hills, looking north, looking out toward the horizon, we see some really complex looking features. Here is where it shows up, again, nicely visible in backyard telescopes. And there are two big craters right next to each other, Aristarchus on the right, Herodotus on the left, but then a roughly rectangular area extending above them has dark patches of volcanic ash and gigantic channels of flowing where lava once flowed. The greatest of these channels is called Valles Schroderi, or Schroeder's Valley. This is the greatest example of one of these sinuous rills on the surface of the moon. The eruptive center is seen there in the lower right. It's about 11 miles across. So this was a big volcanic area. This area is also being targeted by NASA and one of its commercial partners, Intuitive Machines, and we're planning to have Intuitive Machines in a robotic mission carry a NASA payload as well as some payload from other customers to this area as early as this fall. So it could be this year we could see a mission to the surface going to the area near Valles Schroederi. Now, just south and west of the Aristarchus Plateau is this very smooth, flat, quite frankly, boring looking area. This is the P60 basaltic unit, and this is the youngest lava plain that we have found on the moon. It's only about 1 billion years old. That sounds old, but for the moon, that's young. And so being that this is the youngest lava plain we've yet found on the moon, we would like to explore it. Looking from the Aristarchus Plateau, we can see there are other sinuous rills or lava channels. And then looking out toward the horizon, if you look toward the top of the image and a bit to the right, you'll see some interesting looking bumps on the horizon. That's our next area of interest, the Gruithuisen domes. And they occur in this area. Again, great targets for backyard telescopes. If you look at the bottom of this peninsula, here you can see those bumps sticking up there. These are actually lunar volcanoes, but you don't need laser altimetry to see them. These are tall, steep-sided volcanoes, and they're different because unlike the lava in most lunar volcanoes, this lava came out very thick and very pasty, very different from typical lunar lava. Why is the lava here so different? Again, we don't know. And that's motivation for us to go and explore the Gruithuisen domes. Another example of really weird lunar volcanism is Ina, or the Ina D caldera. It's the best example of what we call an irregular mare patch. And this is a real challenge object for backyard telescopes. You can see it right in the center here. It looks like kind of a capital D lying on its side. As we zoom in, we see it as this weird patch of ground. It's actually a caldera, a volcanic crater at the top of a very shallow lunar volcano. And it's got this kind of amoeba-like feature here where you have these low rolling hills inside, but the area around those low rolling hills is remarkably devoid of impact craters. And by inspection, this appears to be really young terrain, only perhaps tens of millions of years old. Now, we haven't been able to figure out how lunar volcanism could have lasted that long. That doesn't fit in with our thermal models. So clearly something is going on here that we don't really understand. And that makes the Ina caldera an irresistible place to visit. Not too far away is the area of Rima Bode. And Rima Bode is just right near the center of the full moon, shows up very clearly as an area that is much darker than the area around it. Again, these are volcanic ash deposits erupted from cracks that opened up in the surface here. You can see one of those cracks. And the ash here from measurements we made in orbit seems to be strangely enriched in actual water trapped inside the ash. Could this water be something that we could use to live off of in future missions? We don't know. It could conceivably be a resource. Mare pits are fascinating features that we want to explore more closely. As we look across the moon, we see lots of holes in the surface of the moon, lunar craters where asteroids slammed into the surface, and a few lunar craters that were caused by volcanoes. But then we see things like this. We call these mare pits that are holes that seem to open up into vast voids beneath. What we think is that these are skylights opening up into subterranean lava tubes. giant caverns where lava was once flowing beneath the surface. So this particular Mare pit occurs in the Sea of Tranquility, the same general area where Apollo 11 landed. This one occurs in the Marius Hills, an area that we'd looked at previously in this talk. Here's one in an area called Mare Ingenii that is on the far side of the moon. We'll talk about that a little bit more. And this is a pit in the area called Locus Mortis. And this pit is particularly interesting because there seems to have been a collapse on the eastern side of the pit, which could actually result in perhaps a ramp that we could even drive a rover down. So this area is particularly interesting. And again, this is in Locus Mortis. So these pits in general are interesting, but Locus Mortis is also an area of particular interest. It occurs in the northern part of the near side of the moon. And you can see it here. It's this big area about 100 miles across, flat except for a big later impact crater that formed called Berg, is that impact crater. But Locus Mortis is about the same age as Copernicus, about 800 million years old. If you look carefully, you'll see these cracks, these fractures on the floor. And these seem to have been caused by lava, by magma rather, rising up from inside the moon, coming up through cracks in the crust and forcing those cracks apart, widening the cracks, forming these faulted area that we call graben. And if we zoom down into one of these fractures here, we'll look down at this lower left-hand edge of that fracture. We can see actually, looks like some of the lava may have made it to the surface in the form of two lunar volcanoes here. You can see them side by side, these rounded domes with volcanic craters on top. So Locus Mortis has a pit, it has these faulted fractures, it has volcanoes, there's a lot going for it. And that's why right now we are planning a mission, again, with one of our commercial partners. This will be Astrobotic, is going to carry a payload of NASA instruments to the moon, along with a number of other payloads, including rovers from the Mexican Space Agency. And that is scheduled to go to the moon later this year. So again, another robotic mission. This will go to Locus Mortis, and it's scheduled for as early as sometime this fall. Another area we're looking at is Mare Crisium. You can see this in binoculars, or even with your unaided eye. It's in the on the eastern edge. It's a big flat lava plain that again was formed a long, long time ago by an asteroid impact. And then after that basin formed, sometime after that, the floor of the basin was flooded by lava. And this is a site that we are planning to send a mission to in 2023. And the NASA's commercial partner, Firefly, is going to again send a robotic lander there. And amongst the various things that we'll be carrying will be NASA experiments. We're still trying to figure out exactly where we're going to land in Mare Crisium. One of the candidate sites that I really like is this area here. This is called Horseshoe Crater, and this is the volcanic cone. Compton-Belkovich is on the far side of the moon, and this is an area that at first doesn't look like much, but it's giving off radiation from a whole bunch of thorium. This is an area where there are, again, steep-sided, thick, pasty volcanic deposits. We're not sure why. If you look at the far side of the moon, you see it's very different than the near side. You don't have the smooth, dark lunar seas to speak of. It's very rugged. We're not sure why it's so different. One exception, though, is there is a small mare area, small lava plain, Mare Moscoviense. The area, the lunar crust here is especially thin. We have volcanic ash deposits. We have lunar swirls. So this area is beckoning to us. The South Pole Aitken Basin is the largest impact structure and the oldest impact structure that we've identified on the moon. It's hard to see because it's so old it's been battered. If we use that laser altimetry, though, we can see down at the bottom the blue area represents low, and we can see this deep blue area, deep dark area that is actually about 2,500 kilometers across. It's hard to see because it's been so battered since then. But this is an area that may have excavated down into the mantle of the moon. And it dates back to the earliest days of the moon. This is one of the earliest features we've been able to identify on the moon. The Schrodinger Basin actually excavates the edge of the South Pole Aitken Basin. And again, it has fractures like we've seen in other areas. One of those fractures has a dark volcanic vent around it. If we look more closely, we can see that volcanic vent has one of those permanent shadows. So you've got permanently shadowed areas, you've got volcanoes, you've got it excavating, one of the oldest features on the moon. This is interesting. The South Pole. This is where, though, we're really spending a lot of effort. The South Pole, we see, again, areas of deep, dark, permanent shadows. This is where we expect to find real deposits of ice that could be great resources for us. Most of the terrain is in deep shadow, but using the Moontrek software, we can zoom in. We can use the laser altimetry to pierce those shadows. We can look at slopes. We can see where the areas of actual permanent shadow are. We can measure temperatures. We can look for areas of frost. We can look at the distribution of hydrogen in the form of ice, probably, and how far down you might have to dig to have ice be stable. In those deep shadows, you don't have to dig at all. This is the area of the planned Artemis missions, where we will be sending humans to the surface of the moon. The first woman and the next man to walk on the surface of the moon will be through the Artemis missions. Now, I've told you briefly, we've talked about the solar system treks. This is a wonderful tool that you can use. Just point your web browser to trek.nasa.gov and you can explore the surface of the moon. You can pan, you can zoom, here we'll zoom into the crater Tycho. And one of the first things you might ask is, well, gee, how big is that? That's really easy to tell, to calculate a distance. It's as simple as drawing a line. So we'll draw a line across Tycho Crater here, and you can measure, it's 83 kilometers across. That's a big hole in the ground. Next thing you might ask is, well, how deep is it? Again, that's as simple as drawing a line. We'll use an elevation profile, draw a line across, and here we can see, we'll submit, we get an elevation profile, we'll scoot Tycho off to the side here. And so you can easily measure the heights of mountains and the depths of valleys. It's really a cool tool. Something else you can do that is really a lot of fun is we can draw a bounding box around any area that you want. And so we'll draw a bounding box around Tycho, and you can then have the option of generating either an STL or an OBJ file to send to your 3D printer. You can make 3D prints of any terrain you want. You can also jump into 3D mode and actually interactively go flying across the surface, fly down into craters. We'll fly down into Tycho here, and we can even go roving across its surface. Again, this is interactive. You're just using keyboard game controls in your mouse. Excuse me. One other really cool feature, custom virtual reality experience. Draw a path with your mouse anywhere you want across the surface. It'll come back to you with a QR code. Scan that QR code into your smartphone, put your smartphone and a pair of cheap $5 Google Cardboard goggles. Whatever path you drew, you will now fly in virtual reality. So again, that's NASA's Solar System Treks at trek.nasa.gov. So with that, I'll be happy to try and answer any questions that you might have. Franz, are you still with me? Oops, not hearing you.
I gotta unmute myself. Thank you so much, Brian, for all of that. That was awesome. I think our viewers really enjoyed that. Just looking up at the moon at night. Sometimes we could take for granted all of the intricate features that it has, and I think that using this software and having you kind of walk us through that just brought a lot of that to light. So I want to thank you so much for that. So yeah, we'll see if we have some questions now. So question is, how can we tell how old the moon rocks are?
Well, that's a real good question. And so once you get a rock in the lab, then what you do is you look for minerals, you look for crystals that formed in that rock. And the nice thing about crystals is that they form in a very specific pattern. Specific atoms go together in a specific way. So when that crystal formed, we know what atoms were in it to begin with. But atoms over time can be unstable, and they can break apart through fission to form different types of atoms. And we know the rate at which that can happen. So if we get a crystal into the lab and we look at how much of it has turned into some of those daughter elements, so how much of it has changed into that other type of element, and we know how fast that happens, we know the rate at that happens, that allows us to actually calculate the age of that crystal. So mineralogy comes to the rescue here. And so when we get those labs, or when we get those rocks into the lab, and we look at those minerals and we look at how they have changed through radioactive decay, we can actually calculate their ages.
So like using an indirect method, you can figure out how old something is. Thank you. Awesome. What is your favorite fun fact about the moon?
Oh my gosh, there are so many of them. There are so incredibly many of them. For me, I think a lot of it is that some of the craters and things we see on the moon can tie to events here on Earth. So for instance, an apparent shower of impacts that created a number of craters, including Copernicus that we looked at earlier, could be tied to events here on Earth that go back to when Earth was covered by ice. Basically, the impacts that the swarm of material that the Earth and Moon traveled through and left these scars on the moon, the Earth probably got hit too. And those scars have long since been eroded away. But we know from the geologic evidence that way back at about that same time, the Earth went through a sudden cold period. And so what we think may have happened is a bunch of impacts hit the Earth, just like what we see recorded on the moon. And that might have kicked enough dust into the Earth's atmosphere to block out sunlight and cause that prolonged period of glaciation. So by going to the moon, we can actually learn stories that tell us about the history of the Earth.
So it's like using the moon as a time capsule, and using the moon, like you said before, the moon doesn't have weather. So, it's almost preserved, it's actually absolutely preserved.
That's right. The moon is a great place for us to understand this environment of the inner solar system where we live. A lot of that history that has been erased by erosion here on Earth is preserved on the moon.
And it's right there. Just a 3-day trip.
Yeah.
It's right there.
Yep. It's right next to us. Yep.
What does a normal day of work at NASA look like for you?
I don't know that I have any normal days, quite frankly. They really vary. It's very exciting. I spend a lot of my time using tools like MoonTrek to study areas on the surface of the moon. I've gotten to do a number of, so I also have gotten to be involved with the study of Mars. And so one of the fun things that I've gotten to do is what we call terrestrial Mars analog studies, where we go to extreme environments here on Earth, places that have things in common with the environment of Mars. So like the Atacama Desert in South America, the driest desert on the face of the Earth, 50 times drier than Death Valley. And it's been arid to hyper-arid since the time of the Triassic, the dinosaurs. And if you want to find a place that looks like Mars, wow, this is it. And you go there, it is so dry that people who live on the edge of the Atacama grow up to adulthood without seeing a drop of rain. In the center of the Atacama, there is no life. There's no plants, no animals. You don't even find cultural bacteria in the soil. It is super arid. You go ahead and sleep out on the ground there. You don't worry about anything coming to bite you. There's nothing there.
Wow.
We were there during the winter time, so the daytime temperatures were only about 110 degrees.
Only.
Yeah, but as soon as the sun set, the temperature dropped below freezing.
Oh, wow.
Because there's so little water vapor in the air to hold that heat in. So this was a great place to go to figure out how will we live and work on Mars, as well as how might life on Mars have adapted to its drying environment. So I've gotten to do that. And one of the other fun things is back in 2007, I got to fly on a mission that went up high into the upper atmosphere to have a front row seat for a meteor shower.
What?
And that was way cool. Yeah. So, there's always adventure, and going to the Cape or here in California to Vandenberg to watch, rocket launches and work launches. It's a great gig. I love it.
Awesome. How will sending humans to the moon first help us in sending humans to Mars later?
Okay. It's an interesting question. Going to the moon is going to take us to an environment that we're not used to living in. This is living in deep space. Yeah, we've had astronauts living on the International Space Station for a long time. They'll be, for over a year in orbit, but they're, completely, essentially weightless environment. And they're still, though, inside the Earth's protective magnetic field. But when you get to the moon, you're in deep space. And it's very different. The way I like to think of it is going to the moon or Mars, living in deep space is going to be a big challenge. When you want to do this, though, let's imagine you're going to go up into the Rocky Mountains. You're going to go backpacking, and you're going to go high up, 14,000 feet up in the Rockies. And so you go to the store and you get a tent and your sleeping bag and your stove and all that equipment. As soon as you buy that, do you head out to the trailhead and head up to the top of the mountains? Heck no. You take it home. You go into your backyard. You learn how to pitch that tent. You learn how to work that stove. You get all that working. And once you got that down, then you go up to the trailhead and up to the mountains. The moon is our backyard. The moon is how we're going to learn how to live and work in deep space. And once we've got that down, then we'll be able to safely proceed to Mars.
So it's the intermediate step before we get.
That's right. It's our stepping stone for going there.
To date, what is your fondest memory of working at NASA?
So that's actually an easy one for me.
Oh, okay.
And there have been a bunch of great memories, but my first lunar mission that I worked on was the L-Cross mission. And that was wonderful. That was exciting. That took up a huge amount of time. And then for the actual launch, that was down there at Cape Canaveral, historic place where, Americans first left the Earth. And I'll take a step back. My mom was a big influence to me. My mom was a grade school teacher, and she really encouraged my interest in science as I was growing up, got me my first telescope. And so, I'm essentially where I am now because of my mom. And so that day of the L-Cross launch, there at Cape Canaveral, in the VIP section, my mom got to sit there and watch as my rocket went shooting up into the sky. That was special to me. I lost my mom this past year, but that was a memory that she and I shared for the rest of her life, was the excitement of her getting to watch that rocket with the mission I was working on launch to the moon.
That's awesome. Thank you so much for sharing that story. And I think we have one last question. What advice would you give a student who would like to work at NASA one day?
Well, I would say that one really great opportunity that is available to you is to come try it out and work at NASA as a student. So we have a series of internship programs, and you can essentially turn NASA into a summer job. And so we have people, typically undergraduate students. There are some graduate students certainly too, but even as young as high school students who will come and do internships at NASA. Now, it's a fun experience, and believe me, it doesn't look good. It doesn't look bad on a college application either, So to find out more about doing an internship at NASA, just go to intern.nasa.gov.
That's awesome information for our viewers, and I think that it's awesome that you guys have that opportunity for young ones to aspire to do things like you do. And I know that a lot of kids think about going up into space and doing the astronaut thing, which is really awesome too. But doing things down here on the ground and starting off with an internship is another way to kind of go out into that field. So that's an awesome opportunity that you guys are offering up.
Yeah, I agree. It's really neat. It's a great way to get started.
So, Brian, that's all the time that we have for today. But I want to thank you so much. We are so grateful that you came to give us your time during this Lunar New Year.
All right.
For coming.
Franz, thank you very much. It's great seeing you again. Thanks for all that you're doing. And again, Happy New Year to you.
Happy New Year to you as well. And Happy New Year to everyone else who's watching. Thank you guys so much. That concludes our broadcast for right now. But we do have a broadcast coming up at 3:00. So up next, we have our virtual tour of the Intrepid Museum. We've talked about the Intrepid throughout this broadcast. And so if you would like to learn a little bit more about the Intrepid and take a virtual tour, you can join us back here at 3 p.m. Once again, ladies and gentlemen, thank you so much for joining us. My name is Franz. I'm a museum educator here at Intrepid, and enjoy the rest of your day.